Hi, my name is Victor Nod, and I am the product manager of the Configure group here at GitLab. My team is responsible for GitLab's Kubernetes integrations, and we are proud to present you our most recent achievement. The GitOps workflow is finally available in the free tier with the GitLab agent for Kubernetes. Pool-based deployments, also known as GitOps, is becoming the best practice for Kubernetes production deployments because of its security and scalability features. GitLab shipped pool-based deployment support initially in version 13.7, but until now, it was a GitLab premium feature. Since the initial launch, we learned what are the important features for our premium and ultimate customers, and this allows us to move the basic GitOps functionality to the GitLab free tier. The GitLab agent for Kubernetes, unlike other GitOps tools, is not only for pool-based deployments, it's the basic building block of all the GitLab Kubernetes integrations. As of today, besides GitOps workflow, it supports GitLab CI/CD-based deployment as well and operational container scanning in a single tool. Similarly to the impersonation features available for the CI/CD workflow, we plan to add more access control to the GitOps functionality, and those features will be GitLab Premium only. At the same time, we believe that small teams or high trust teams should be able to use the agent fully and simplify their DevSecOps stack following the GitLab vision of a single platform for the whole DevSecOps lifecycle. After this long introduction, let's see a quick demo of the feature available in GitLab Free. As you can see, I already installed the agent into my local cluster. Moreover, I prepared this repository to host a few files for us. That we will deploy into the cluster. This is really just for demo purposes. So let's see the files that I want to deploy. They are today, right now, under the packages directory. We have a namespace. Basically, the agent, once the pool-based deployment happens, we create a namespace for us called the demo agent. And the other item that I will speak a bit longer as well is this config map, which it's called agent demo inventory. I will speak why it's a special config map. I won't speak much about about the airbag in the third item. It's for other demos that I use the same repo for. You can see here in the namespace that there is no demo agent namespace in the namespace list. So this namespace does not exist today. Similarly, if I go to, let's say, all namespaces and look up the config maps, there is no config map with this agent demo inventory name. So these are the resources that will be created in this demo. The agent is configured within GitLab in code itself. You can see the configuration file for this agent here. And in this case, the configuration points to manifest directory, and all the YAML files from this directory will be watched by the agent architecture, and they will be deployed whenever they change. To simplify this demo, I will only copy the packages directory where these three files exist under the manifest directory, as you can see it here. And we see how the agent picks up the files from under the manifest repo, under manifest directory, and applies them to the cluster. So once I commit these changes, this GitLab CI/YAML CI job will run, and it will copy these files to the final position within the repository. A similar CI job could run, in theory, a customized build or a Helm template command as well, and you could save the output of those commands back to the repository, as I do now the copying. To follow along, first let me start the logs for this agent. It will soon appear, and after that, I'm going to commit the CI file that I created here. So, yeah, update GitLab CI. That's exactly what I want. And let's commit directly to main branch just to simplify our life for the demo. Okay. So what happens first is that the CI jobs have to run, and by default, it was set up to run on when the files under packages change. So I'm going to run it by hand. It might take a few minutes to run. Until then, I will pause the recording. You could see the first logs, even though appeared because there was a commit happening in the repository, the commit of this change that I made, but there is nothing to sync. Still, we said the objects got synchronized. Let me put in word wrap, a line wrapping here. So objects got synchronized, but there were no objects actually. At the same time, the pipeline is almost over, and it's over now. And immediately the agent picked those up, and seemingly everything worked. As we can see, there was a namespace, an airbag that I mentioned I won't speak much about, and the config map as well, somewhere around here. I've seen before. Inventory action. No, that's different. Anyway, there's the config map as well, but let's see if they are really there. We are back to the namespaces list, as you can see, and there is the demo agent namespace that we expected to have. And if I open again all the config maps, then you can see that here under the GitLab agent namespace, we have the config map from the repository itself. Oops, this is wrong one. You could say that, okay, this concludes the demo, but actually I would like to give you a bit more information about why do I deploy this surprising config map. The agent was initially built on shared code base with Argo CD, but we decided to move away from that shared code base primarily because of its quality features. And today the agent is built on something called CLI utils. CLI utils using inventory objects to keep track of the managed resources. This approach scales better than simply using labels on the applied resources. Moreover, in the end, the inventory object is actually just a config map with a unique hash, in this case, agent demo inventory. And the data attribute, the config maps data attribute contains actually a reference to all the resources managed by that inventory. As you can see here, but we don't see the data. Anyway, that's what it manages. If no inventory object is available, then the agent will actually create an inventory object for us. And besides this really elegant management of the resources, CLI provides other amazing features. The most important one is very likely server-side applies. So the agent uses server-side applies out of the box without setting up anything. This allows you to use the pool-based deployments together with tools like horizontal put autoscalers. Even though both resources might change the same deployment resource, the fields define who owns specific fields, and the server-side applies knows how to handle all the conflicts if conflicts arise. What are our plans with the agent, you might ask? What comes next? Please note the disclaimer at the very top of this page. Everything here is only for informational purposes, but we do have quite a few plans. We just finished moving the basic GitOps functionality to GitLab free. This is what I'm speaking about right now. And we have a few other tools like adding direct support to harm and customize into the agent, and to support better scaling into more manifest projects. Like today, the manifests are in the same project where I store the agent configuration itself and when the agent is registered. In the future, we want this to allow the manifest to be stored outside of this project in other private projects as well. This concludes my demo. I hope you will try out the agent if you deploy to Kubernetes, and we are more than interested in your feedback. So please reach out to us via GitLab issues and let us know if you like it or if you don't. Thank you. Have a nice day.